Hello. In this video, we're going to go over finding the normal line to a function at a given x coordinate. We have covered one of these videos before with chain rule. In this one, we are going to do two methods to show that we can do chain rule and quotient rule. You can decide which method is best for you. Woohoo! All right. Again, when we are looking for the normal line, we need the derivative of the function. The derivative of the function is the slope of the tangent line. However, we don't want the tangent line. I want the normal line. And the cool thing we know after that is the normal line is perpendicular to the tangent line. So once we find that slope, we find the negative reciprocal, we have our normal slope. Then we just need a point. We can just plug the x value back into our original function, and we'll get our xy coordinate point that we are going to need. So let's start with that. First, I'm going to plug 5. Well, let's rewrite it as f of x, right? Let's clean it up. F of x is equal to 2 over x minus 3. We're looking for when x equals 5. So let's find f of x of 5. 2 over 5 minus 3. 5 minus 3 is just going to put us over 2, and we see that 2 over 2 is equal to 1. My function's point that we are going to be testing is 5, 1. Next, we need to find the derivative of f of x. F prime of x can be found in two separate ways. First way we're going to do is we're going to write f of x, and we're going to do a quotient. We have 2 over x minus 3. If we recall quotient rule, we have h of x is equal to f of x over g of x. H prime of x is equal to f, derive of f, the numerator, keep the denominator. We're going to have to make this much smaller. Keep the denominator, subtract, derive the denominator, do not change the numerator, all over the denominator squared. That's how we do our quotient rule. So in this situation, we'll start labeling. F of x is the numerator. G of x is the denominator. We are going to derive f of x. We see it's 0. We will then derive g of x. We see it's 1. So now we're going to just plug into our little formula here, right? So we first see that we have f prime, which is 0, times g of x, which is x minus 3, minus g prime, which is 1, times f of x, which is 2, all over x minus 3 squared. Okay? So now we're going to plug in, because this is what we get when we're looking for f prime of x, right? Because that's what we're looking for. We are now going to plug in. Well, let's clean this up a bit. This turns into 0. F prime of x is equal to negative 2 over x minus 3 squared. And we're going to plug in 5 for x. So again, x equals 5. Let's put that in a different color so it stands out. Make it red. X equals 5. Let's plug it in. F prime of 5 is equal to negative 2 over 5 minus 3 squared, which is just equal to negative 2 over 2 squared, which is equal to negative 2 over 4. Simplify it one last time, negative 1/2. So the slope of the tangent line right here, f prime of x, is negative 1/2. So slope of tangent line is equal to negative 1/2. But I don't care about the tangent line. I want the normal line. I need to find the slope of the normal line. Well, based on what we discussed earlier, the slope of the normal line will be the perpendicular of the tangent line. Well, what's perpendicular to negative 1/2? It's negative 1/2. It would be 2, the negative reciprocal. We flip it, so 2 over 1 take away the negative sign or change the sign from negative to positive or positive to negative. And we clean it up and we see it's just 2. That is all. We have our slope. We have our point. We will now plug it all into our answer. Y equals mx plus b. So now we plug in y is 1, mx is 5, m is 2 plus b. We have 1 equals 10 plus b. Subtract 10 to both sides. B is equal to -9. My final answer is y equals 2x minus 9. That is the equation of the normal line to the graph of this function, at x equals 5. Not too bad once you kind of get used to it. I need to select everything. Bear with me while we make this a little smaller, because there is another method that we could have done. Let's bring this guy over here. There is another method that we could have done to make our lives a little easier if you prefer not to do quotient rule. You prefer chain rule. So let's do over chain rule really fast. So this goes to here right after that. All right, so that was quotient rule. We're going to get the same. Remember, we're only solving for the slope in this situation just so you can see the 2 different ways to derive. So we have f of x. And now in this situation, I'm going to bring up the x minus 3 to the -1 exponent that we know we can do with exponent properties. A negative exponent brings a denominator to the numerator or a numerator to the denominator. In this situation now, we have an easy chain rule. The first we see the outside system, which is the power rule. Then the inside system, which is another power rule. The outside, we have -1 times 2, -2. The inside does not change when we do the outside system. Remember, we can only do one system at a time. -1 minus 1 is -2. Let's move this over to the left a little bit. And then we multiply that by the derivative of the inside system, which is just 1. Derivative of x is 1. Derivative of -3 is 0. We will clean this up. F prime of x is equal to -2, x minus 3, and we'll bring that to the denominator and make that exponent positive. If you notice, that is exactly the same thing that we have here. And if I were to plug in x equals 5, we would still get the exact same thing that we have solved over to the left. And that should show you that whatever method that speaks to you while deriving is the method that you should go for. I prefer chain rule. However, if you see quotient rule, do quotient rule, no harm, no foul. If you have any other specific questions you would like me to cover, especially with normal lines, just send me an email and I'll gladly create a video for you. Other than that, I hope everyone has a great day.